This is the conservation of momentum lab where we'll be looking at three different types of collisions. The first collision we'll be looking at is a elastic collision. For this elastic collision, the cart's masses are very similar. So you can see that one cart transfers just about all of its momentum to the second cart. We need to analyze some data here, so we'll use the tools in Logger Pro. We're going to be doing a linear fit on the position versus time graph to find a velocity for each cart, both before and after the collision. The values will come up on the screen in a few moments. When we look at the velocity versus time graph, down on the bottom there, we can use the shape of that graph to identify this as a elastic collision. We'll notice that in that bottom graph, one cart starts off with zero velocity, the other cart has some. In the middle of the graph, you can see their lines cross where the first cart gives its momentum to the second cart. So just take a moment and record your data, and we can come back later and do the calculations. The next collision we'll be looking at is a purely inelastic collision, where the carts start off separately and then move off together. For this collision, we want to analyze the same parameters that we did for the elastic collision. We're going to use the linear fit tool to find our velocity of each cart before the collision, and also to find our velocity of the carts after the collision. Again, the velocity would be the slope of the position versus time graph. And you can notice how the two carts move off together. Another way of identifying this as being a purely inelastic collision is by looking at the velocity versus time graph. And you can see how the carts start off with differing velocities and then move off together with approximately half the velocity, each cart having the same velocity. You can just take a few moments and record your data on your lab sheet. And again, we can come back later and do all of our calculations. The final collision we'll be looking at is the recoil collision. For the recoil collision, both carts start off together and then move outwards from each other. Once again, we're going to want to find the velocities of the cart before and after the collision. Since the carts are at rest before the interaction, their beginning velocities would be zero. We can find the after velocities, again using the linear fit tool. Now if we were to look at the velocity versus time graph, the bottom graph, you can see that both carts initially start off together and then in a very short period of time gain velocities in opposite directions. And that's the way we can identify a recoil collision. So take a couple moments and record your data on your lab sheet. And then after this, it would be time to go ahead and do your calculations for each of the type of collisions. Okay, you should now have all your values so you can do calculations for each collision. For each collision, you will calculate the momentum of cart 1 before the collision, momentum of cart 2 before the collision, the total momentum before the collision, just by adding cart 1 and 2 together. And then you want to do the same thing for after the collision, the momentum of cart 1, the momentum of cart 2, the total, and then finally you want to measure the change in momentum, which would be your momentum after the collision minus your momentum before the collision. We should find that the change in momentum should approximately equal 0 if all of our settings were correct.